Hey guys, I hope you're well, and I hope you had a fantastic Easter. Okay, cool. So today we're going to be looking at the math library in Python, and we're just going to evaluate all the functions in it, and yeah, just give you examples, how it works. Okay, cool. So on a side note, I would really appreciate it if you guys actually subscribe to my channel. If you like what you see, hit the subscribe button, and I'll greatly appreciate that. So thanking you in advance. Cool. So let's get started. So from math import asterisk there. I can also do it this way, so import math as m. Right, so the difference is, with the first method, you can just evaluate a function without typing anything, just type in the function. Then the second method, you always have to type in m, then the function. Sorry, m dot, then the function. Okay, right, so it's just personal choice. I just prefer using the first one. Okay, right, so I'm going to start off with my arc calls. So arc 0.2. Okay, so that's the arc cos of x. So my x is 0.2, right? Then arc sine, and I'll just think of a number 1. Okay, and then arctan 0.1, right? And then arctan, then 2. My value would be 3 there, and 2. So that's the y over x. So where my y is 3 and my x is 2. Okay, and then the arc cosh. So that's the inverse of the hyperbolic cosine of x. I'm just going to think of a random number. I'll just use 2 there again. Okay, and then the arc sine. So the h is obviously the hyperbolic part. Okay, a random number 0.3. Then arctan 0.2. Right. Okay, and then my function ceiling. So I'll think of 3.6. So what this does is it returns integer greater than or equal to x. So my x is 3.6, so that's going to be 4. Okay, and then obviously the cosine. Okay, and cosh. So that will be the hyperbolic function of cosine. Okay, and then copysin. So right, I'm going to think of a number, so I'll put 3, and then minus 2. So that would return minus 3. So it copies the sign of the second digit and brings the first digit out. So, okay, and then so degrees. So what that does is it converts an angle x from radians to degrees. So 1.57 radians. So that'll tell you what it is in degrees. Okay, and then the error function of a value. So I'll put 2. Then the error function, the complementary error function of x. I'll put 2 again. Okay, right. Then exponential, I'll say 1. Right, and then exponential, so m minus 1. So I'll put a value there 2. So what this does is it returns So e x minus 1. Okay, and then fabs. That's 62, so it's just a random number I thought of. So that returns the absolute value. Okay, and then factorial. Let me just think of number 3. So 3 factorial, so that's 3 times 2 times 1, so that's 6. Okay, and then flow. Think of a digit 3.2, so that'll be 3. Okay, and then f mod. Right, so what this does is of 10 divided by 3. Oh, sorry. 10 divided by 1, my bad. 10 divided by 1, which is 0 anyway. Yeah, sorry, my bad. And, okay, the other function, so what this does is, so we get the man theta. So that's in numerical analysis and exponent of x as the pair me. Okay, right, and then the f sum. So I've got a sequence. So 1, 2, 3, 4, 5, 6. So all it does is adds all those numbers together. So you get 21. Okay, and then gamma of x. So this is so the gamma function. Okay, and then hypot. So 2 and 3. I think that will do. So what this function does is it's the Euclidean square root. Okay, and then is finite. So that would be a Boolean function, either true or false. So true. Okay, and then is none, not a number. So I'll think of a value. So let me say 6. So that's false. Okay, and then is infinite. So that's false again. Okay, then I've got my function. So 2 and 3. Right. So that returns okay, and then So continuing further, so natural log of gamma. Okay, and then log 1p. So there's 3. So what this does is, so we get the natural log of 1 plus x. Okay, so we just say log 4, same value, right? Okay, cool. Right, and then log 2. So natural log. So okay, so the log in base 2. Okay, and then log 10 through. So that's the log in base 10 as well, right? And then you can specify a base that you want. So log, right? And then I'll say 2. And the base will be, let me say 3. Okay, sorry. Here we go. So log in base 3. Okay. And then after that, I'm going to look at so mod f. Okay. So what this does for us is it returns a fractional and integer part of x. Okay, so there we are. And then pi evaluates the value of pi, and then power. Yeah, so power. So I can just think of so 3 raised to the power of 2, which is going to be 9. Okay, and then radians. So this would convert an angle in degrees into radians. So 180 degrees. So which is pi. Okay, and then okay, and then my square root. So square root function, I'll say 400. So that'll be 20. Okay, and then tan. So the value say 0.5. There we are. And then tan. I'm going to use 0.5 again. And then trunk. So that think of a value 3.2. So what this does is it returns the truncated value, integer value of x. Cool. So yeah, so this is it. So this is what I wanted to show you in the functions that are in the math library. Okay, cool. And just to go back to the top, yeah, so that one with the f mod, so that's going to be 0 because there's no remainder. So because when 1 goes into 10, it goes 10 times without a remainder. So that shouldn't be 10 divided by 3. It should be 10 divided by 1. So I do apologize for that. Okay, cool. So anyway, thank you guys for watching, and hope this was helpful, and hope you have a lovely day. Okay, cool. So thanks for watching. Have a lovely evening.